Hi everyone, it's Miss Ann here. Today we're going to do 2 HSC questions on z-scores. A z-score tells us how many standard deviations a value x is from the mean, the average. And normally there are 3 types of questions they will ask. Asking for below x, then you just use the table. And above x, the total probability, take away the table value. Another one they could ask is between 2 values, A and B. In this case, you just find the difference of table values. So let's have a look at 2023 paper. Question 38, it's a 4 marks. Random variable is normally distributed with a mean of 0 and a standard deviation of 1. Now, what does that really mean? In here, the mean, the average is a 0 here. That's mu. And then your standard deviation, mu plus 1 standard deviation. And then below the average is the average take away 1 standard deviation. So that's what it really means. The table gives the probability that this random variable lies below z-score for some positive values of z. We have z-score on the top and the probability values on the bottom. The probability values given in the table are represented by the shaded area in the following diagram. The weights of adult male koalas from a normal distribution with mean mu equals 10.40 kilograms and standard deviation sigma equals 1.15 kilograms. In a group of 400 adult male koalas, how many would be expected to weigh more than 11.93 kilograms? So we're looking at the question, this one. So it's more than 11.93 kilograms. I'm going to use this bell curve here. This is the 10.40, my average mu. First standard deviation above the mean, 10.4 plus 1.15. 11.55, so I've got 11.55, and then 1 standard deviation below 10.4, take away 1.15, which is 9.25. This z is 11.93. We need to find the z-score that it's going to represent the below the 11.93 kilograms. Now, most of these questions, there are very simple steps you need to use. Okay, I just wrote 3 steps I was talking about. Step 1, I'm going to convert x to z-score so I can use the table. I'm going to write all the information that are given. X was 11.93. Mean, mu is 10.40. My standard deviation, the sigma, is 1.15. Now, z-score formula is z equals x minus mu all over sigma. 11.93 take away 10.4 all over 1.15. If you put that in your calculator, you will get 1.33. Now, that is my z-score, and I need to convert that to probability, which is less than 11.93 kilograms. Now, from the table, 1.33 probability value is 0.9082. Now, this is probability of all the koalas that are less than 11.93 kilograms. So this is not the answer. So what we have to do now is we need to take away from the total probability, which is 1. So probability of more than 11.93 kilograms equals 1 minus the probability of less than 11.93. So that'll be 1 minus 0.9082 will give me 0.0918. What it's saying is about 9.18% of male koalas are more than 11.93 kilograms. So how many number of male koalas that more than 11.93 equals, is there about 400 of them times 0.0918, 36.72, and I will say 36 koalas or 37 koalas. Both answers are acceptable. Question 35, this is from 2024. A random variable is normally distributed with mean 0 and standard deviation 1. The table gives the probability that this random variable is less than z. The probability values given in the table for different values of z are represented by the shaded area in the following diagram. The scores in a university examination with a large number of candidates are normally distributed with mean 58 and standard deviation 15. Part A, by calculating a z-score, find the percentage of scores that are between 58 and 70. So this is the between one, so which is just find the difference of table values. Now, good thing about this one is 58 is also mean. So the z-score will be 0. So first step, converting to z-score. My x is 58, so my z will be 58, take away the mean, 58, 15 equals 0. Now, if I convert this z0 to probability of 58 marks is 0.5 because it's in the middle. When x is 70, my z-score will be 70 take away 58, the mean, and then divided by 15, the standard deviation, will give me 0.8. I'm going to convert this. Probability of 70 will be from the table 0.8 is 0.7881. To find between 58 and 70, I just need to find the difference of two table values. Probability of between 58 and 70. Now, by the way, you can write this like this. 58 x 70. Okay, so that will be 0.7881, take away 0.5. Always take away from the bigger number because we don't want to have a negative probability or the percentage. So that will give me 0.2881, but we haven't actually answered the question yet because question said find the percentage. So this is not a percentage. So we need to convert that to percentage by timesing it by 100. So which will be 28.81%. Okay, part B, okay, this is a quite common questions now. Explain why the percentage of scores between 46 and 70 is twice your answer to part A. If you want to show it, you could draw the diagram. So I've got this diagram here. So this is my mean, the mu, so 58. I'm going to call this one as my 70, this one as my 46. My z-score here was 0 and this was 0.8 from the part A. Now, between 70 and 58, there's a 12 difference. So I can say 58 plus 12 equals 70. And it just happened to be 46 is 58 take away 12 will give me 46. So between 46 and 58 is 12. Also between 58 and 70 is 12. So I can say the z-score for 46 is minus 0.8. So what does that mean? It means this area between 46 and 58 is identical, symmetrical with the area between 58 and 70. That means it's going to be twice bigger. So what I'm going to write here is, by symmetry, the area between 46 and 58 is the same as the area between 58 and 70. Therefore, the percentage of scores, I'm just writing whatever it says here. Copy that down because that means you're answering the question. Between 46 and 70 is twice 28.81%. Okay, part C. By using the values in the table above, find an approximate minimum score that a candidate would need to be placed in the top 10% of the candidates. Now, I just copy the table here from the question. The question is asking to find the minimum score, let's call it X, that needs to be in the top 10%. What does that mean? It means we want the minimum score to be in the top 10%. This means we need to look for the z-score closest to 90%. So when we look at probability, which one is the closest to 0.9000? I can see that when z-score is 1.3, my probability is 0.9032. That's a fairly close to 0.9000 from the table. When z-score is 1.3, my probability is 0.9032, which is 90.32%. So it's very close to 90%. To find X, we need to use the formula. Z equals X minus mu all over sigma, which is 1.3 equals X, we don't know. Mu is 58 and standard deviation was 15. Okay, so X minus 58 equals 15 times 1.3, which will give me 19.5 plus 58 on both sides. X equals 19.5 plus 58 will give me 77.5. So roughly 77 marks or 78 marks is the minimum score to be in the top 10%. So that's all for this video. Hope it helped. See you next time. Bye.